Well, I've been avoiding inequalities. It's kind of a little tricky, but I think you're up to it. I want to talk to you once again to remind you I've got another scale. I had one before, a wooden one, but I always actually have 3 of these scales, and every time I see one I like better, I buy it. This one's kind of dusty. I think I could write my name in it. Anyway, look at that. What if we had this balanced? Oh dear, it just went off. That's why I needed that wooden one, because it was much more stable. But it's unfortunately down in my art studio, and I don't want to go get it. So if we have an equation, remember I told you it was sort of like a balance, and the main thing, maybe I should just put this down. You remember, don't you? What you do to one side, you have to do to another. And that's usually a good thing to remember and all the time when you're dealing with equations. Now, when I teach the next thing with one unknown, not yet 2 unknowns, when we deal with the next thing with one unknown, it's usually like what I have here is inequalities on the number line. Inequalities. That means instead of things being equal, they're unequal. I usually tell students that you treat the inequalities just like you do equations, with one difference. And if you can memorize that one difference, this becomes easy. But sometimes it's hard when things look alike. It's easy to think you know everything right away because you're used to what you do to one side, you do to the other. So we're going to do some experiments. Now, I'm going to bring up this whiteboard so that I can write some problems for you. And before we do this, I want to delve into the realm of proof. Now, giving an example is not a proof, but giving an example that shows that something is a lie is enough to kill off a proof. Now, some people think that if they have an inequality, let's see, when we had an equation, remember we could add, subtract, multiply, and divide both sides of the equation by the same thing, and the equation stays true. Now, what we're going to say is that's almost like that. But I'm going to take a simple example like 2 is less than 4. Everybody knows that's true. I'm not using an X here. We're just using numbers so that we can sort of verify. This is not a proof, but let's take adding. What if we added 2 to both sides? We would get 4 is less than 6. Is that true? Yeah. What if we had changed it to 3? It would have been 5 and 7. 5 less than 3. Looks like we can add to both sides now, but I better be careful because maybe I could be fooled. What about maybe negatives act different? I'm going to push clear on this. I'm going to go back to 2 is less than 4. What if I subtract 1 from both sides? We're still working on adding, and remember, subtracting is just adding the opposite. So add, subtract. We get 1 is less than 3. Still true. With me? Stay with me. It's going to get weird. What if we had 2 is less than 4, and then we subtract something like 5 from both sides? Then we get negative 3 is less than negative 1. Is that true? We're still testing adding. Is owing $3 lower in richness than owing $1? Sure enough. So negative 3 is less than negative 1. Now we've experimented and we found that if we added or subtracted a number from both sides of this inequality, everything seems all right. Now this was not an actual legitimate proof, just a demonstration. But I want to say that it's true. Okay, got that? You can add and subtract from both sides of an inequality and things stay the same. Now let's go on to multiply and divide, because division is just multiplying by the reciprocal. So I'm going to clear this again, and let's take something that's easy, like let's do 2 is less than 4 again. What if we multiplied both sides by 4? We get 8 and 16. Is that true? Does that seem still right? 2 is less than 4, 8 is less than 16. Looks okay. I might jump to the conclusion that I could multiply both sides by the same thing. But watch. Here comes weirdness. Are you ready for it? You need to be paying attention. I'm looking at the wrong place, so it doesn't look like I'm looking at you. But watch out. Weirdness happens. Okay, so I'm going to clear this. We're going to take 2 is less than 4. And this time, instead of multiplying by positive 4, let's multiply by negative 4. Adventuresome. We get negative 8 and negative 16. Is negative 8 smaller than negative 16? Is owing $8 worse off than owing 16? No, the lowest number here is the negative 16, not the negative 8. Oh my goodness, something strange has happened. When we multiplied by a negative, it didn't stay true. Oh, actually, we have to do what I used to tell my students so that they could remember. When you multiply by a negative, you have to do a switcheroo. Switcheroo? What is it, you say? What is it, you say? If I can only find eye contact with you. What is it, you say? We have to take this less than and change it into a greater than. And now it's true. Isn't that strange? When we multiply by a negative, we have to do the switcheroo. Oops, I can't switch. Aroo. Is that like Winnie the Pooh? Switcheroo. Now, since division is just multiplication, sort of in another form, what if we said 2 is less than 4 and we divide by 2? We get 1 is 2. 1 is less than 2. We divide by a positive, everything's cool. But what if we divide? What if we divide? What if we divide by a negative? What if we go 2 is less than 4 and divide by negative 2? I'm sorry, I can't look at you and look at this at the same time. Maybe I am. I don't know. Who knows? Divide. 2 divided by negative 2 is negative 1. 4 divided by negative 2 is negative 2. Now, which one is smaller? Oh, it would be this one. Some of the kids, when they come up from middle school, they always say that the arrow points to the smaller number. But look, we had to do a switcheroo. So, I want to make a conclusion here for you to memorize. You must memorize this, and inequalities will be a snap. Are you ready? Okay, I'm clearing this out, and we're going to say that when I'm going to put this in red too, and make it large, we multiply or divide by negative on inequalities. Might as well get back to black. You need to have, let's make it switch. This is not a math, it's switcheroo. I don't think that's a mathematical, that's not a mathematical. Oh, I left out a C. Switcheroo. Switch. I can't even spell the words. I make it myself. Switch. Aroo. That means you turn the inequality. Got that? So we can work some of my problems from my program and see how this works out. I'm going to clear this and minimize that, and we're going to go to inequalities on the number line. We're going to try problems. Okay, here's a problem. Oh my goodness. I know that this is going to be a switcheroo problem before I start, because I see that before all is said and done, to find out what the x is, what am I going to have to do? I'm going to have to divide by negative. I said the dirty word, divide by negative. It's going to be a switcheroo. Are you with me? I hope so. I hope I'm not doing this for no reason. Okay, so we're going to get this up here, and I'm going to try to copy this problem. Negative, I still got the red, negative 4x minus 28 is less than negative 28. That's a strange problem. Welcome to the world of random numbers. I think I'll get this down to black again. Well, if this had been an equation, if my dreams had come true and this was an equation, the first thing I would do would be to get rid of this negative 28, just like we always did. I would add 28 to both sides. This is going to be a little weird. And see where we go. I'd end up with negative 4x and 0. And if it were an equal, it'd be just equal, but I'm going to put less than. Now, the next thing I have to do is get rid of the negative 4. What is it doing to the x? It's multiplying the x. How do you get rid of multiplication? You divide. I have to divide this side by negative 4, and I have to divide this side by negative 4. So I end up getting x, and on this side I get a 0. But because I divided by a negative, I have to do the switcheroo on the inequality. So the answer is x is greater than 0. Let's see if I can put that in. X is greater than 0. I put the 0 in here, but this is wrong, so I'm going to click on that. And now I check my answer, and it's going to say, you're right. Now we want to locate the end point of our inequality. It's here, 0. Now click on the side of the graph that should be shaded. Well, x is greater than 0. Where are all the points that are greater than this end point? It's over here. We win. One right. Let's do one more problem and we'll be done with this movie. Remember, you treat inequalities the same way that you do equalities, except if you multiply or divide by a negative on both sides, you have to switcheroo the inequality. I wouldn't say the word switcheroo too much. Just think it in your head, okay? Just don't forget it. Take care. I'm going to work one more problem. Bring up my whiteboard here, and we're going to have, this time I'm not going to have to do any of that because I can see right off. I'm not going to end up dividing by negative. I've got just a plain old x. 1x minus 6 is less than negative 2. I want to get the x by itself, so I'll add 6 to both sides. It's almost boring. X is less than 4. No switcheroo. I didn't add or I didn't multiply or divide by a negative, so there's no switcheroo. So I have x is less than 4. We check. We win. Locate the endpoint of the graph, which is 4. And now we have to decide which side is shaded. Where are all the points that are smaller than 4? This is what the graph looks like. I really should put a little arrow on the end of that. Okay, we got that right. Hope you can see. You can probably work inequalities. I think there are some in the essential algebra. So let's just get good at solving inequalities on the number line. Take care. Bye. I hope this helped. Bye.